In this video, we'll be talking about section 3.5, and this video will cover just kind of a review of minimizing, maximizing, optimizing profit, cost, and revenue functions. So every single problem in 3.5 is recommended. This first video, we're going to go through the first 26 problems. So it's going to be a longer video, but then we're going to change topics when we come back and start talking about elasticity of demand in that video. So let's go ahead and get started here. Number one gives us a revenue function of 800x minus 0.2x to the second power. And so we're going to differentiate and get 800 minus 0.4x. To find the critical numbers, which is part of what we need to find here, we need to set this first derivative equal to 0. We get negative 0.4x is equal to negative 800. And I've got my calculator over here. Negative 800 divided by negative 0.4 is going to be 2,000. So our question asks us, find the number of units X that maximizes the revenue. And we just found that. If we want to prove that that's a maximum, we should find the second derivative here, which is going to be negative 0.4. So it's going to be R double prime. It's going to be negative for all X values. And then because R double prime of 2,000 is less than 0, R has a maximum. When X is equal to 2,000 units. All right, let's look at our next problem, number 2. Number 2 says R is equal to 48x squared minus 0.02x to the third. So that makes R prime equal to 96x minus 0.06x squared. And that factors into a negative 0.06x times x minus 96 divided by negative 0.06, negative 1,600. We're going to set that equal to 0. At negative 0.06x equals 0, or x minus 1,600 is equal to 0. So x equals to 0, or x equals to 1,600. You can imagine which one is probably the right answer, but let's use the second derivative to help us prove which one is the right answer. So the second derivative here is equal to 96 minus 0.12x. And so that means that this is, set that equal to 0. 96 minus 0.12x equals 0. Negative 0.12x equals negative 96. negative 96 divided by negative 0.12 is 800. Making a sign chart for my second derivative here, our double prime. Here's 800, and to the left of 800, a number like 0, 96 minus 0 is a positive number. And then to the right of 800, like 1,000, we would have something like 96 minus 120. That would be a negative number. So we have a, if C is less than 800, our critical number less than 800, then we have a local minimum. If C is greater than 800, we have a local maximum. So this is a local minimum, and this is a local maximum. We're interested in the local maximum. So we're interested when X is 1600. So because our double prime of 1600 is greater than 0, there has a local maximum. When X is equal to 1600 units. All right. Let's go ahead and make some space for our next problem, number 3. Number 3 says that R is equal to 900x plus 222x squared minus x cubed, which makes R prime equal to 900 plus 444x minus 3x squared. I'm going to set that equal to 0. I'm going to factor here, negative 3 times x squared minus 148x minus 300 is equal to 0. I'm not just dividing through by that negative 3, because if I did that, I'd change my sign of R prime here. And I want to keep track of all my positive and negative factors here. So negative 3 is a negative factor. It needs to sit out there. So negative 3 times x and x. And we have 300 is going to be 150 and 2. They have a difference of 148, and the 150 needs to be negative, and the 2 needs to be positive, so that they add together to give me a negative 148. Now, if I set this equal to 0, that's going to be that x is equal to 150, or x is equal to negative 2. X equals negative 2 doesn't make any sense, because we're talking about production. We have to have a positive number of units. Let's prove that there's a local maximum at x is equal to 150. So R double prime is equal to 444 minus 6x. And when we set that equal to 0, 6x equals 444, and x is equal to 222 over 3. So x is about is exactly equal to, is exactly equal to 74 units. So here's 74 units, and to the left of that, like when x is 0, we get 444 minus 0. That's a positive number, meaning that anything less than 74 would give us a local minimum. To the right of 74, like 100, 444 minus 600 is going to give us a negative number, meaning that there would be a local maximum to the right of 74. Since 150 is to the right of 74, that means that we can say since our double prime of 150 is less than 0, R has a local max at x is equal to 150 units. Let's look at number 4 to finish up this little section of problems on maximizing revenue. And the revenue equation given to us here is that R is equal to 30x to the 2/3 minus 2x. So that means R prime is 30 times 2/3 x to the 2/3 minus 1, then minus 2 on the outside. 3 goes into 30 10 times. R prime is going to be 10 times 2 is 20. X to the 2/3 minus 1 is 2/3 minus 3/3. 2/3 minus 3/3 is going to be R prime. It's equal to 20x to the negative 1/3 minus 2. I'm going to set that equal to 0. And that's 20x to the negative 1/3 is equal to 2. So x to the negative 1/3 is equal to 2 divided by 20 is 1/10. So let's write that as 1 over x to the 1/3 is equal to 1 over 10. Cross multiply here. X to the 1/3 is equal to 10. Let's cube both sides. And x is equal to 10 to the 3rd, which is 1,000 units. And we did not find our double prime yet. Let's find our double prime. So R prime was 20x to the negative 1/3 minus 2. So our double prime is going to be negative 20 thirds x to the negative 1/3 minus another 3/3. Our double prime is a negative 20 thirds x to the negative 4/3. Our double prime is going to be a negative 20 over 3. And then this is x to the 4th inside of a cube root sign. So when I do that, no matter whether x is positive or negative, when I take it to the 4th power, that's going to make it positive. So I'm going to always have a negative divided by a positive. So that means that R double prime is less than 0 for all x's not equal to 0. So we have, since our double prime of 1,000 is less than 0, R has a local maximum at x equals to 1,000 units of production. All right, that was number 4. Let's move on now to number 5, which is going to be finding minimum average cost. Just maximize revenue. Let's minimize average cost now. Clear this canvas here. So that's going to be number 5. Gives us a cost equation C of 0.125 x squared plus 20x plus 5,000. So C divided by x is what C bar is, average cost. So we're going to divide everything by x, take the power of every term down by 1. 2 minus 1 is 1. 1 minus 1 is 0. There's x to the 0 is just 1, plus 5,000 x to the negative first power. So C bar prime, since I want to minimize this, it's going to be 0.125 minus 5,000 x to the negative second power. And let's go ahead while I'm at it and find C bar double prime in case I need to use that to prove that I have a minimum. So this is going to be a negative times a negative will be a positive, and that will be 10,000 x to the negative third, or that will be 10,000 over x to the third. So C bar double prime is that. So now we're going to set this equal to 0, and we're going to solve for x to the negative second here. So negative 5,000 x to the negative second is equal to a negative 0.125, and that negative 0.125 divided by a negative 5,000 is x to the negative second is 2.0.0000025. All right, so that means that if I take the reciprocal of this, let's see, let's do it this way. 1 over x squared is equal to 0.0000025 over 1. So cross multiply 0.0000025 x squared is equal to 1. So x squared is equal to 1 divided by 0.0000025. 1 divided by 0.0000025 is 40,000. And I want the square root of that. Is 200. Since I'm concerned about production here, I don't want a negative answer for x. X has to be a positive 200. So let's go back and look at C prime of 200 will be a positive divided by a positive will be a positive because C prime of 200 is greater than 0, C bar has a local minimum when X is equal to 200 units of production. Right? Let's look at number 6. Number 6 says that C is equal to 2x squared plus 348x plus 7200, which makes C bar, which is C over X, equal to 2x plus 348 plus 7200 x to the negative first. So C bar prime is equal to 2 minus 7200 x to the negative second. And that makes C bar double prime equal to 104, 0. So that is 14,400 x to the negative third. C bar double prime is 14400 over x cubed. So when I set this equal to 0, I'm going to go ahead and do this a little different than I did last time, where I'm going to multiply on the left-hand side by x squared over x squared to put that x squared into the denominator. And then I'm only worried about this numerator being 0. So that's going to be when x squared minus 3600 is equal to 0 and x squared is equal to 3600. X will be plus or minus the square root of 3600 is going to be plus or minus 60. But I'm concerned about production, so I'm only interested in positive 60. And then because C double prime of 60 is greater than 0, there C bar, excuse me, has a local min at X equals to 60 units of production. Let's look now at number 7. Number 7 says C is equal to 0.001 x to the third plus 5x plus 250. So that makes C bar equal to 0.001 x squared plus 5 plus 250 x to the negative first. C bar prime is equal to 0.002 x minus 250 x to the negative second. C bar double prime is going to be equal to 500 x to the negative third, or 500 over x to the third. Now when I set this equal to 0, I'm going to multiply by x squared over x squared, and I get 0.002 x to the third minus 250 over x squared is equal to 0, making 0.002 x to the third minus 250 equal to 0. 0.002 x to the third is equal to 250. 250 divided by 0.002 is 125,000, and cube root or raised to the 1/3 power that answer. So second math, cube root is number 4 of 125,000. Give me x is equal to 50. Notice because it was an odd power, it's not plus or minus, it's only positive. And that because C double prime of 50 is greater than 0, C bar has a local minimum at x is equal to 50 units of production. Okay. Let's go ahead and look at number 8. C is equal to 0.02 x to the third plus 55x squared plus 1,380. So that makes C bar equal to 0.02 x squared plus 55x, and it makes C bar prime equal to 0.04x plus 55, which makes C bar double prime equal to 0.04, just that positive number. So C bar double prime is going to be positive for all x values here. So, hang on, I forgot a term here. It's 1380 x to the negative first. This is minus 1380 x to the negative second, and that is plus 2760 x to the negative third. That looks better to me. So that is 0.04 x to the third plus 2760 over x to the third. We'll figure out what's going on with C bar double prime once we find a critical value. So let's set this equal to 0, and let's multiply everything by x squared. So 0.04 x to the third plus 55x squared minus 1380 over x squared is equal to 0, meaning that 0.04 x to the third plus 55x squared minus 1380 is equal to 0. I'm going to multiply, I can multiply by a positive number on both sides and not change the problem. So let's go ahead and multiply everything by 100 to get rid of that decimal point. 4x cubed plus 5500 x squared minus 138000 is equal to 0. And then I have a invisible plus 0x in here. So I want to just go, I'm going to go ahead and graph and see where my 0 is. might as well just do it with this because I'm going to use the graphing calculator here. So no reason to do rational root theorem when we have the calculator right in front of us. 4x to the third plus 55x squared minus 1380. And let's zoom 0 to make sure we see the interesting part of the graph. Let's see here. Let's just zoom 6. I have a feeling that, there we go. I'm interested in that x-intercept right over there. So second calc. Number 2, I'm not interested in negative production. I'm only interested in positive production over here. There's my cursor getting pretty close to it. I'm on the negative part of the y-axis there. I'm on the positive part of the y-axis there. I'm real close to 0 right there. In fact, I'm exactly at 0 right there at x equals 5. So C prime of 5 is equal to 0. So let's see if there's any other zeros that are interesting. 5 on the outside, 0.04, 55, 0, and negative 1380 will be 0.04. That's 0.2, 55.2. And this is 0, carry the 1, 26, 27, so 276. 276 times 5 is 1380. This is 0. So that tells me that I have x minus 5 times 0.04x squared plus 55.2x plus 276. Let's go ahead and look at that function and see if it has any zeros that I'm interested in. So squared and 55.2x this is 0.04x squared plus 55.2x plus 276. Graph, zoom 0, and it looks like its vertex is to the left over here. It has one x-intercept there that was to the left of 0. So I'm not interested in that one because that would be negative production. That doesn't make any sense to me. It's got 2 negative x-intercepts that are not interesting to me. So I don't really need to solve this piece. My only thing that I'm interested in is 5 is a critical value. So let's look at what C double prime of 5 is. So y equals alpha y equals n over d. To get the fraction, 0.04 x to the third plus 2760 for my numerator. My denominator is x raised to the third power. Second, table settings, set my independent to ask. Second table, I want 5. to make it evaluate, and I get that's a positive number. So because C bar double prime of 5 is greater than 0, C bar has a local min when X is equal to 5 units of production. That's number 8. Let's move on now to number 9, which takes us to a new section on maximizing profit. They're going to give us a demand equation that correlates production with price, and they're going to give us a cost function. So number 9 says that my demand function P equals 90 minus X, and my cost function is 100 plus 30X. So you need to know that revenue is equal to the number of items that you sell times the price that you sell those items at. So that's X times 90 minus X is equal to 90X minus X squared. And you need to know that your profit function, capital P, is equal to R minus C. It's your goes in as minus your goes out as, your revenue minus your cost. So that is 90X minus X squared minus 100 plus 30X is 90X minus X squared minus 100 minus 30X. Let's combine those like terms to get 60X minus X squared minus 100 for your profit function. So if we want to maximize profit, P prime is going to be 60 minus 2X. Let's just have P double prime over here in case I need it. It's going to be a -2, so that's always negative. Whatever my critical value is that I find here is going to represent a maximum for my profit function. So 2X is equal to 60, X is equal to 30 units, because P double prime of 30 is less than 0. P has a maximum when X is equal to 30 units. That's now they're going to ask us what price we should sell at to make this maximum profit happen. So lowercase p at 30 is going to be 90 minus 30 is going to be $60. So we should set our price at $60 so that people will buy 30 units, which will maximize my profit. Let's go ahead and look at number 10. Number 10 says that little p price is equal to 70 minus 0.01x. Capital C cost is 8,000 plus 50x plus 0.03x squared. So revenue is equal to XP is equal to 70x minus 0.01x squared. Capital P profit is revenue minus cost is 70x minus 0.01x squared minus 8,000 plus 50x plus 0.03x squared. Capital P profit is 70x minus 0.01x squared minus 8,000 minus 50x minus 0.03x squared. Capital P profit is 70 minus 50 is 20x. And then we have negative 0.01 minus 0.03 is minus 0.04x squared minus 8,000. So P prime is 20 minus 0.08x. And P double prime is going to be negative 0.08. No matter what my critical value is, it'll represent a maximum profit. So I set that equal to 0. And negative 0.08x is equal to negative 20. Negative 20 divided by negative 0.08 is going to be x equals 250 units. And because P double prime of 250 is less than 0, P has a local max at x equals 250 units of production, but we need to actually find the price that forces that maximum to happen. So lowercase p of 250 units is 70 minus 0.01 times 250 is going to be equal to 70 minus 2.50. Let's just type this in the way that it was given. 70 minus 0.01. 1 times 250 is going to be equal to $76.50 for my price point. Go ahead and look at number 11. Number 11 says that P is equal to 50 minus 0.1 times the square root of x. And capital C is equal to 35x plus 500. So that makes my revenue equation xp is 50x minus 0.1x to the 1.5 is 3/2 power. And that makes my profit function, which is r minus c, 50x minus 0.1x to the 3/2 minus 35x plus 500 in parentheses. So capital P is 50x minus 0.1x to the 3/2 minus 35x minus 500 is 50 minus 35 is 15x minus 0.1x to the 3/2 minus 500, which makes P prime equal to 15 minus, and then if we just call this 1.5, that's fine because we're dealing with decimals everywhere else. So negative 0.1 times 1.5 is negative 0.15. X to the 1.5 minus 1 is 0.5. Then we want P double prime over here. It's going to be negative 0.15 times 0.5 is going to be a negative 0.075, x to the 0.5 minus 1 is negative 0.5. Just leave that in case I need it for what p double prime will be, negative 0.075 over x to the 0.5. So when we set this equal to 0, we have negative 0.15 x to the 0.5 is equal to negative 15. So negative 15 divided by negative 0.15 is 100. X to the 1/2 is equal to 100. Let's square both sides. And x is equal to 10000. Now, we already said what x to the 1/2 or x to the 0.5 is here. P double prime of 10000 is negative 0.075 divided by 100 will be negative 0.00075, which is less than 0. So because p double prime of 1, that's 10,000, sorry, is less than 0, p has a local max at x is equal to 10,000 units. Okay. And so now I need to find the price that forces that. So P of 10,000 units is equal to 50 minus 0.1 times the square root of 10,000. And that square root of 10,000 we already know is 100. So that's 50 minus 0.1 times 100. That times 0.1 moves the decimal point one place back to the left. So this is 50 minus 10 is $40 for our price point. Let's look at number 12, which is the last one in this little section here. And it says that my demand function P is 24 divided by the square root of x. It says that my cost function is 0.4x plus 600. So x times P is my revenue. It's 24x to the first divided by the square root of x is 24 times the square root of x for my revenue function. And my profit function is r minus c, so that's 24 square root of x minus 0.4x plus 600. Capital P profit is 24x to the 1/2 minus 0.4x minus 600. So that makes P prime equal to 12x to the negative 1/2 minus 0.4. And that makes P double prime equal to a negative 6x to the negative 3/2, or a negative 6 over x to the 3/2. So when we set this equal to 0, 12x to the negative 1, let's multiply by x to the 1/2 over x to the 1/2 here. 12 minus 0.4 x to the 1/2 over x to the 1/2 is equal to 0, meaning that 12 minus 0.4 x to the 1/2 is equal to 0. Means negative 0.4 x to the 1/2 is equal to a negative 12. Negative 12 divided by negative 0.4 gives me, what did I type in wrong? It's divided by key twice. So x to the 1/2 is equal to 30. When I square both sides, x is equal to 30 squared is 900. Now I don't want 900 units. What I want is the price that will help me to sell 900 units. And we should probably prove that negative 6 divided by 900 to the 3/2 power is a negative number here. It is, but p double prime of 900 is, fraction, is a negative 1 over 4,500, which is less than 0. So because p double prime of 900 is less than 0, p has a local max at x equals 900 units. I'm interested at little p, price of 900 units is equal to 24 over the square root of 900 is 24 over 30. 24 over 30 is going to be 80 cents. So when we set our price of whatever this is to 80 cents, we'll sell 900 units of that and we'll maximize our profit. I'm going to go ahead and stop the video here. We're almost at an hour, and I'll come back at problem number 13 so that we can make these videos a reasonable length each, and you're not watching a 2-hour long video. So come back next time and we'll finish up problems 13 through, I think it's 26. Yeah, we'll do the next 13 problems or so in the next video. So see you for the next video.